Just like polynomial equations, polynomial inequalities have a standard form. The standard form of a polynomial equation is polynomial equals 0. For a polynomial inequality, its polynomial has some inequality to 0. If we have a polynomial inequality in standard form, well, if we want to solve it, just like a polynomial equation, we factor it first. So that's the only new step given a polynomial inequality in standard form. Instead of being given the polynomial factored, we have to factor the polynomial. So here's an example. We're given this polynomial inequality, and this side is 0, so we are in standard form. Our first move then is to take this polynomial and factor it. So I notice that all of those are even numbers, and I like positive leading coefficients. So I'm going to start by factoring out a -2. So factoring out a -2, I'm left with x to the third plus 2x squared minus 9x plus 2. And my next step is to try grouping, since this has 4 terms. But I can see that grouping will not work. So I'm factoring x to the third plus 2x squared minus 9x plus 2. Grouping fails. I see I have 2 sign changes. I have 2 or 0 positive roots. Substituting -x, I have 1 sign change. I have 1 negative root. And my leading coefficient is 1. So my q is plus or minus 1. My constant is 2. So my p is 1 or 2. Okay, that's not too bad. I'm going to try 1 first, because that makes the arithmetic easy. And my coefficients are 1, 2, -9, and 2. 1, 1, 3, 3, -6, -6, -4. Not 0. 1 is not a root. Let's try 2 right away. 1 times 2 is 2, plus 2 is 4, times 2 is 8, minus 9 is -1, times 2 is -2, plus 2 is 0. Okay, 2 was a root. So now my polynomial is -2 times x minus 2 times x squared plus 4x minus 1. Now I'm down to a quadratic. I think I'm going to use completing the square. X squared plus 4x minus 1 is 0. X squared plus 4x is 1. Let's see. X squared, and then I've got a 2x and a 2x. So x times x, either 1 times 2, 2 times 2 is 4. I'll add 4 on both sides. So x plus 2 squared is 5. X plus 2 is 1 of the square roots of 5. So x is -2 plus or minus the square root of 5. So my factors, I have a -2, I have an x minus 2. I have an x minus negative 2 plus root 5, and x minus negative 2 minus root 5. What does that look like on a number line? Well, I have 3 zeros, and negative 2 minus root 5 is the smallest because that's negative. Negative 2 plus root 5, well, that's smaller than 1, right? Because root 5 is smaller than 3. And then 2 is my last one. So x minus 2 is 0 here, here, and I've got a 0 here. Negative 2 is negative always. X minus 2 is negative when x is a small number, and positive when x is a big number. X minus anything is negative when x is a small number, and positive when x is a big number. It doesn't really matter how big these things I'm subtracting from x actually are. X minus anything is always negative when x is small, and positive when x is big. So the sign of my product, well, it's 0 wherever one of the factors is 0. It's negative in this first column because I'm multiplying 4. And then in this first column I have 4 negatives, the product is positive. 3 negatives, the product is negative. 2 negatives, the product is positive. 1 negative, the product is negative. Okay, now we look back at the original inequality. We want greater than or equal to 0. So that means we want equal to 0 and we want positive. Our solution set, we have negative infinity up to this first cutoff point, negative 2 minus root 5, and that number is included. Union, the second cutoff point, negative 2 plus root 5, up to 2. And both of those endpoints are included. That's our solution set. So here we need to combine what we know about factoring polynomials with what we've just learned about analyzing the signs of polynomials. There really aren't any new steps involved here, only combining the things that we already know.